Let us begin. Thank you so much for coming. So we've got an ambitious agenda today. I'm hopefully going to bring you from not so much to from scratch to knowledge about how GPT and generative AI work and answer some of your questions in just a little bit of time. But for those of you who don't know me, I'm Harry Surden. I'm the interim executive director of Silicon Flatirons, head of our AI and law initiative, and also just an ordinary old AI and law professor as well as a bunch of you in my class. So thanks so much for coming. What are we going to talk about today? So today we've got a lot to cover. We'll talk about what is generative artificial intelligence. We'll do an introduction to ChatGPT and large language models. Then we'll figure out, then we're gonna see how GPT works. We'll look at word vectors, neural networks, pre-training, transfer learning, transformer and attention mechanism, instruction fine-tuning, none of which most of you know right now, but I'm gonna explain this in really simple language. So hopefully when we come out the other side, non-technically oriented students will have a sense about how this amazing technology works. And please hold all questions to the end, because we got a lot to go through. So let's start right out. What is generative AI? Well, kind of a more basic question is, what is artificial intelligence? So there's no agreed upon definition of artificial intelligence. Lots of people will have their own. But I find one useful definition is the following. Using computers to solve problems, make predictions, answer questions, or make automated decisions or actions in the kinds of tasks that when humans do them are thought to engage intelligence, higher order cognitive activities. So think something like driving, you have to be thinking and using your visual acuity, or chess, or problem solving. These all engage higher order thought processes. So when computers do them, and they do them quite differently, or when they're able to solve that kind of task, we call it an artificial intelligence task. So generative AI is a specific set of artificial intelligence that is focused on creating creative outputs that are generally associated with humans. So these are things like art, music, text. So for instance, I used AI to create the logo for our conference. I could never have drawn that myself. So let's just look at a couple of these examples. Generative art is really interesting. There's something called Midjourney, but there's some other companies out there. There's one from OpenAI called DALL-E. But you can basically type in anything you want and get anything. So what about if I wanted to take Mona Lisa and show her in the style of Pixar, the most famous painting in the world? I could never do that. But with Midjourney, I just do this. There you go. Or say I wanted a picture of a robot law professor teaching a law class. Again, not something I could ever draw, but with generative AI for Midjourney, it's pretty easy to do in just seconds. So I encourage you all to try these really interesting tools. You can pretty much generate anything you want, high quality art. It's quite amazing. So that's generative art. There's also generative music. You can create AI enhanced music. This is a song I created. So pretty impressive, given that I don't really know much about music, and there are lots of AI-generated music sites out there for generating. You can generate incredible music in any genre. You can create voices that sound like particular artists. It's opening up all sorts of new frontiers. But of all those, the most important one in my view, is generative text. This is the real big one that's going to change our society. So this is what we really need to focus on here. So these are things such as ChatGPT, GPT, models that can generate text. So this is where I'm going to focus the most of our time because this is by far the biggest breakthrough of the three. So let me dive in on that. So what is ChatGPT or GPT in large language models, and why do I say those differently? So how many of us have played with ChatGPT here? Okay, so a lot of you have played with it. So ChatGPT is the chat-based interface to an actual underlying technology called GPT, which we're going to understand. So that's not the only way you interface with it, but that's one way. And GPT was originally developed by a company named OpenAI, and we'll talk about them a little bit more. But it was designed just to be an automated text generator, so it could make stories or poems or articles or blog content in the style of people. And that was kind of interesting, so I had to write this funny poem about CU law using ChatGPT. And, it's kind of a nice little poem. In Boulder, where mountains stand tall, lies a law school revered by them all, with a strong legal mind and a heart warm and kind. CU law sets the standard for all, right? Sounds pretty accurate. So that's pretty impressive, and that alone would have been amazing, but we're going to see it can generate many more amazing things. But let's take a little bit of an overview of what it means. So GPT, those words, those letters stand for Generative Pre-trained Transformer. And we're going to break down each one of those words, and hopefully you guys will understand what it means. So let's just start with generative. So as I said earlier, something like GPT is considered generative because it's generating text. As we will see, it generates text one word at a time based upon all the other text that's come before it and what you've asked it. So it's called generative because you can use AI for all sorts of other things besides generating text, driving cars or predicting things. So it's kind of saying this is our use of AI. It's generating text. Pre-trained, again, we'll talk about this, but this is one of the magic keys of GPT. So pre-trained means they took basically a huge portion of the internet, and they took tons of actual books, most of the laws, and they took this algorithm and kind of set it loose on vast quantities of text, and it learned huge numbers of patterns about reasoning and how language works. So that's the process of pre-training. We'll see that's this very expensive process of getting the AI to learn the patterns of human thought and language. So that's the P in GPT. And another word you might see out there are large language models, or LLM. So something like GPT is known as a large language model because it uses lots of language, vast quantities of language during its training to learn the different patterns of thought or language. And then finally, the T part, this is the transformer. We'll be talking about this too, but basically this was an invention by Google in 2017 in a paper called Attention is All You Need. It was a breakthrough in AI because it taught something like GPT to learn how to understand the context of the words that are being asked around it. So previously, these things couldn't really understand, and I say that in quotes, they couldn't understand what you were asking it. And this was one of the big breakthroughs that allowed these models to be responsive and actually kind of understand. And the transformer is basically something, a particular architecture, a way of doing something called deep learning. So this is our high-level overview. And the next 15 to 20 minutes, we're going to learn what all of these things mean and come out the other side and be AI experts. But just a little bit of history here. So GPT was developed by what was originally a nonprofit research center that turned into a for-profit called OpenAI in the Bay Area. And they built upon Google's transformer architecture. They took that and they made many huge improvements to get to the state of the art where we are now. They released GPT-1 in 2018. It was interesting. GPT-2 in 2019 was kind of okay. GPT-3 in 2020 was the first one that could generate pretty lifelike text, but it didn't really seem like useful AI. The most important breakthrough was ChatGPT, which you guys have used. The original version came in November 2022, and that was a huge breakthrough, as we'll talk to, based upon two of these improvements that OpenAI made, called instruction fine-tuning and reinforcement learning from human feedback. Again, we'll learn what that means. But there was a massive breakthrough, and then GPT-4, so ChatGPT is known as GPT 3.5, and now GPT-4 was released just last month. It's only available to people who pay for it, or actually Bing Chat, which you can get for free, uses a Microsoft version of it. It's a little bit surly, actually, but it's basically as capable. It's incredibly advanced. So most of the things I'll be showing here today are GPT-4. It was just released last month. Okay, so to understand how good ChatGPT and GPT is, it's really important to highlight how bad the technology was, or how not good it was just last year. And I'm talking early 2022. So which is a huge leap from early 2022 to late 2022 that shocked almost all AI researchers. So when GPT-3, as I said, came out in 2020, it was pretty good. And then they made a couple of improvements up through early 2022. But they weren't really that good, other than generating kind of fake Twitter posts or things of that nature, kind of simulating human text. So luckily we can go back in time and see what these things were capable of back then. So let me play that again. There's something called the OpenAI Playground, where you can look at these old models, not old, like 2022, and play with them. They're kind of frozen in time, and time machine of the way the technology was just a year ago. So if you ask it a common sense question, and I've listed these common sense questions that I've been using over the years to test these machines to see if they can do reasoning, and they would almost always fail. Right? So here's one of them. I would ask something you would ask a toddler: how many legs does an apple have? And a toddler would laugh and say, an apple doesn't have legs. And the old GPT confidently told us it was 6. And then I asked it, write a motion for summary judgment. Not very good, right? This would not pass muster. So many of us were, thinking at the time, maybe 5-10 years from now, we'd be at the point where we could answer a question like, how many legs does an apple have, or things like that, but that's a long way off. But we were wrong, because in November 2022, ChatGPT came out, which had huge advancements. And it wasn't just its ability to generate funny poems like I showed you. It was its ability to engage in reasoning and problem solving. And that was totally unexpected among AI researchers. We thought it would be able to generate text. We thought that was totally expected. We didn't expect it to be able to reason and solve problems. So here's a good example of a really hard problem. I couldn't solve it. Something with like coins and things of that nature that you might find in a puzzle book. And this thing can solve that, no problem. And that was totally shocking, because it doesn't seem like a system that just predicts one word at a time to generate text could also do problem solving and reasoning. This kind of shocked everybody. It was not at all expected. It was an emergent property of this model. Another thing that was super shocking to most researchers like myself is the ability to, quote, understand what was going on. And I say understand in quotes because we don't want to anthropomorphize these systems, right? These are still machines. There's no evidence that they're actually thinking or they're sentient or anything like that. They're just really good at responding. They're good at simulating. They're amazing at simulating. And but we never had systems that could basically take anything you asked it and respond sensibly to it as if it understood. So that was amazing. There was that you can, and if you, to this day, you can ask ChatGPT just about anything about any topic, and it will respond sensibly. Or in the past, these things would not respond sensibly at all to arbitrary topics. That was a huge breakthrough. And then researchers like myself thought, wow, back in November 2022, I wonder if this thing can do stuff with law. And it turns out it can, a lot of stuff, as we will see. But here's an example of it writing a patent application, GPT-4, for a made-up substance called acetylate. And wow, I teach patent law. It can generate a first draft patent that could definitely pass at least first muster at the patent office, and no technology could do it that well on an arbitrary input. So that's amazing. I've gotten it to draft contracts. I mean, just about any legal document, you can say it can generate a first draft, maybe not what you want to turn in to a judge, but definitely as good as, in my opinion, like an okay first-year associate's first draft, which was shocking because you saw this is what it, in early 2022, this is what it could generate, and this is what it can generate now. So here I am just, you see the instruction there, write a motion to dismiss. I just copy just a random complaint I found on the internet from a real case, plugged it in there, and there it's off to the races. It is filing filling in the law, filling in the content. It is amazing. Again, you want to verify, you wouldn't want to turn this in directly to the judge, but nor in my experience would I want to turn in the first draft of an associate directly to the judge, right? I'd want to make sure that everything was okay. And we'll see, it does make mistakes, and we'll talk about that, but it is kind of amazing. And in 1 year, it went from this to that. I mean, this is what is shocking, I think, everybody. Here's another example. Remember the Apple question? How is GPT-4, the latest version, handling the Apple question? Well, let's see. So if I zoom in, how many legs does an apple have? Be sure to explain your answer thoroughly. I mean, it's incredible. And then I decided to push its reasoning and state of the world reasoning abilities, asking it about if it can follow the apple. So I mean, this is amazing in my mind. So basically I asked it, if a person had an apple and then another person went in another room and there was chomping sound, what would you assume happened? And it's like, oh, well, the person in the other room was eating the apple. And then I asked it, based upon what you know, if the first person had intended to eat the apple and hadn't given permission, how would they feel about the other person? It's like, they'd probably feel annoyed and frustrated. That is amazing. It has a theory of mind, again, in quotes, because we don't want to anthropomorphize it. It's able to follow things from different rooms. This is mind-blowing, and I've been studying this for 20 years. So I think it's no hesitation to say this is one of the biggest breakthroughs in artificial intelligence in the last 20 years. This is a big deal. So we're going to find out how it works. And you will come out the other side in the next 15 minutes understanding all of these things. So let's just take a deep dive into how it works. Okay, so the first and most important thing, or not, the first thing we need to understand is the idea of word vectors. So these are also called word embeddings. You'll see them somewhere, but the general idea, there's a huge breakthrough, is the fact that you could take the meaning of words and encode them mathematically. So no one really thought you could do that back before this happened in 2012. So this was invented by Google, again, one of the bigger breakthroughs, and also Stanford came up with this. So the basic idea, and we're going to see how this works, is that you can encode the semantic or the meaning of a word like dog, cat, bird, or house, or any word really, as a list of numbers. So think of it like each row in a spreadsheet is a different word, and then each column is a list of numbers called a vector. That's just math for a list of numbers. But these are like 1,000 columns, right? And then each column represents a different aspect of the word. So it doesn't quite work like this, but if you see the word dog going across, right, there are all these different things that you could classify any word along. So imagine if you had categories for anything and you could put it in any category, right? So a dog is a pet, it's an animal, but it's not a building, and it's not a planet, right? And imagine any possible thing, 12,000 of those that kind of describe any word out there, right? You could characterize that. So the reason it doesn't quite work like this in the real world, I'm just sort of explaining, is that there aren't these clean categories like pet and dog, but for our purposes, we'll just pretend it's like that because it's actually close enough for that. So if you look at the dog here, it's all the numbers are from -1 to 1. So a dog scores a 0.9, right? It's really high. It's a pet, right? It's got fur, so it's 0.8. It's not a building, so it's -0.9. It is an animal, et cetera, et cetera. And then look at cat. A cat is also a pet. It's also got fur. It's also not a building. It's also an animal. A bird is a pet, but it doesn't have fur. It's got feathers. Okay, you get the point. So how does it come up with this, right? So basically, it reads text and learns word in context. So say you were to release this on the internet. Somewhere out there, somebody has written kind of similar sentences about cats and dogs, right? So someone wrote, I took my blank to the vet. I took my cat to the vet. I took my dog to the vet. So it learns to associate, cat and dog are kind of similar, right? I like to pet my blank. I like to pet my cat. I like to pet my dog. So it turns out if you do this 1 billion times, it starts to learning the mathematical similarity between words that are used together. Or think of like king and queen, right? The blank sat on the throne. The king sat on the throne. The queen sat on the throne. The king is royalty. The queen is royalty. So if you break it down along all the dimensions you can think of, they'll start to have mathematical similarity. So this was a giant breakthrough, and it turns out that it actually worked. It was kind of shocking to me because I was like, there's no way that's going to work. How can you possibly encode the meaning of words in math? But it turns out it really works. So here's an example of like, you see, if we have pets on one axis, this is like in math class, if you remember, the x-axis and the y-axis, and animals in the other, it'll kind of group the animals together, but nudge the pets closer. So like bird is kind of in the middle because some birds are pets and some are not. Almost all cats and dogs are pets, but cows are not really considered pets, right? For the most part. I mean, it's kind of amazing that it does it, but it's all because of the way we talk about things and write it down, right? So you'd be like, the cow is a farm animal, whereas the cat is a pet. But it both learns that they're animals, but it kind of nudges them mathematically away. So this is the key idea, is that it's really mind-blowing. I mean, I hope your minds are blown, because my minds are blown, that you could encode word meaning using numbers automatically by just releasing these algorithms on the internet and seeing what words are used together and kind of writing that down. So these are called word vectors or word embeddings, and this is a crucial breakthrough that's allowed GPT. Okay. That's number one. Number two, neural networks and deep learning. So neural networks is kind of an old technology, believe it or not, it was actually invented in the 40s, but it wasn't really 1940s, right? I guess it can be 2040s, that hasn't happened yet. But it wasn't really perfected really until 2012. So that's where an area of deep learning called deep learning came about, which is basically taking these neural networks and scaling them up. So on lots of data. So what is a neural network? Basically, it's very loosely inspired by the human brain, but it's not really the way the human brain works. So it's like a rough analogy. And it's just a way of learning patterns from data and encoding them. So it's part of machine learning. So I'll just show you like visually. It's often drawn like this. And what you see here are what are known as the weights or parameters. And we'll see more how this works in a second. But basically what these kind of lines represent are how important each connection is to the next connection. So you kind of can think of it like a series of committees. Imagine the lowest level committee here says, oh, the cat sat on the what? And then a bunch of people in the committee vote. And one person's like, banana. And another person's like, donut. And then someone's like, well, I'm kind of the expert in this area. I think it's Matt. And I'm like, no, be quiet. You don't know what you're talking about. It's banana. And then they voted up the chain, and then they picked banana, and they find out, no, that was wrong. Go back and figure out what you did wrong. And then you're like, well, we should have listened to that third person, actually, who's saying Matt, right? Next time we'll listen to that person better. So that's a little bit the way it works, and the way we'll see this in action in a second. But the general idea is that this is a super flexible technique for encoding patterns. Basically, you can code any pattern. It's been mathematically proven that any pattern can be encoded in a neural network. So instead of just a couple of these, imagine 175 billion of these. Okay, so that's what GPT has, not however many I have up here, 7 or whatever. Okay, so now we're starting to put stuff together. Okay, so we take the neural network that we just learned, which learns patterns from data. We know about word vectors, right, which are taking words and representing them mathematically between what's around them. Now along comes GPT, and says, let's just run this whole thing on the whole internet and like 2 million books and see what happens, right? And no one had done that before because it was really hard to do. Takes a lot of computational power. And what they did was they basically they said to the neural network, I want you to read every sentence and just try and predict the next word. And then if you happen to predict the next word, that's good. We'll give you a thumbs up. But if you predict the wrong word, right, we're going to go back and find out who told you to predict the wrong word. And we're kind of demote that person and promote the person who was saying predict the right word, right? So that's called, I don't want to use jargon, but that's the learning aspect of it, right? You're constantly looking for, trying to predict, see what you predicted, and then you kind of demote the people who sent you down the wrong path and promote the people who sent you down the right path. And it turns out if you do that 1 billion times, you get this amazing problem-solving machine. So let's see an example here. So if you see this little green weight here, let's imagine that weight, the plus is saying you take the cat sat on the blank, let's send it through the thing, and the top arrow is saying send it to the top path to banana. I think that's right. And the one on the bottom is like, no, it really should be Matt, but it's -3, so no one's really listening to it, right? So let's watch this little example here. It goes through and then comes up with banana, right? And then it detects that it gave the wrong answer because it knows what it should be, because it has the actual sentence, the cat sat on the mat, it's just blanked it out, right? So then it compares what it predicted to what it knows the text should be. It's like, oh, we got it wrong. We predicted banana. Let's go back and correct that. Let's demote that guy and promote that guy, right? And now next time we'll send it down a different path because we want to send it down the path of the one that was telling us Matt. And now let's try it again with these new weights or parameters. And then see what happens. Okay, this time it's going down that path and then comes out and wow, it came up with the right answer. Oops. So that is what's known as training, right? You're training it. It's initially random, and then doing that billions of times, you kind of nudge it up and down 170 billion parameters, and you teach it the English language and reasoning. I know it's amazing. And then this wouldn't have been possible, though, without the mathematics of it, right? And this is where the transformer comes in. So this was, again, Google's invention here. And this takes advantage of the fact that we can represent words as vectors, as numbers. So what do you do? Do you ever think you just said, like, what do you do if there's a word like crane, which has two meanings, bird or the construction equipment? Like, what do you do with that? How do you represent that mathematically? Like, which is it? Is it one or the other? So it turns out it's kind of smushed together as both, and that's not really so helpful. So what Google figured out was, hey, why don't we take what's being asked, and kind of sentence, and see if we can kind of nudge it towards one meaning or the other based upon the context. So here's a good example. So here's the context unaware meaning of the word crane as a word vector, meaning that if we see bird on this axis, a machine, what you get just by reading the internet is somewhere in the middle, right? So it doesn't really know what are you asking the bird, but then along came the transformer, and it said, well, why don't we look at what's being asked? So look at this sentence here. In the serene wetland, a large-legged bird waded through the shallow water. And it's like, oh, well, you can mathematically figure out that we're asking for the bird version of it, not the crane version, by nudging it mathematically towards space. So I'll show you how this works. Like, it literally nudges it mathematically that way. Like, not quite physically, but like that way. So when you put it through the transformer, it nudges mathematically. So we now have a version of crane, which is closer to bird. And that encodes the meaning, the crane version of bird. The vector that comes out is like crane nudge towards bird. And now it can like understand, oh, you're talking about the bird. But imagine if instead you would ask this: workers around the construction site operating many machines, the tallest of which was that. And it was like, oh, I see machine, construction site. I'm going to mathematically nudge it based upon that context. We're supposed to nudge it that way. Let's pretend it nudged it that way. It was supposed to nudge it up there, right, towards machine. So it's really amazing. And the general idea is that these transformers, which GPT is this architecture that takes into context, has 96 layers, and the new one might have more. And as you're working your way through at the split second, it nudges it in such a way along every word that it mathematically encodes the context of what's being asked, plus what it's said so far. So GPT can look back at what it's said so far and be like, oh, I'm telling a story, let's keep going with that. And then it looks at what was asked, and it mathematically encodes all of that in 12,000 dimensions, and that's how meaning is encoded. Like, it's kind of it's shocking. Like, I can't believe it that it actually works. Nobody really thought it could. Okay, and then three more things, and then we'll answer questions. The other breakthrough was this idea that it's called transfer learning. So OpenAI gets credit. They said, let's just unleash this thing on the whole internet and 2 million books and just scale it up. And let's just see what happens. Maybe if you make it large enough, this thing can start doing other tasks we never trained it for. So that was never the case with other AI systems before. Usually it was kind of a narrow task, like driving a car or classifying cat images or detecting faces. It was never like we can just do anything, but they're like, well, let's just train it on everything. Let's convert the entire human output, textual output, compress it in a neural network of 175 billion parameters, and just try lots of things on it. And it turned out it worked. You can take this general thing and then apply it to like almost any task: poetry, coding, it was kind of shocking because that had never worked. But that's called transfer learning, rather than creating a AI system that did a very narrow thing like driving a car, which itself was kind of amazing. It says, like, let's just make this general thing and see if it can do like anything. And it can. Okay, so what's really fascinating, I think this is important to understand, the capability in 2022, in January 2022, was actually lurking in GPT-3, right? That was the model that said, how many legs does an apple have? 6, right? It seemed really dumb. But the researchers at OpenAI were like, we believe this capability is in there. We just need to pull it out by clever engineering. So what they did was they did something called instruction fine-tuning. And they basically said, we're going to take this general model that's been trained on the internet and all that, already knows language, and we're going to give it thousands of examples of what a good question is and a good answer is that anybody could ask. So, write me a computer program to make a dot bounce around a screen, and then somebody programmed that up and gave it to GPT-4. Write me a press release. What would that look like? I'm sorry, gave it to GPT-3. Right, whatever, write a limerick, gave it. So they did 15,000 of these, right? And then it turned out it got really good by seeing these examples. So that was one way of kind of nudging this kind of dumb model into ChatGPT. So that was one huge breakthrough. No one had really thought to do that before, but it required thousands of humans to do this. So OpenAI to spend, probably millions of dollars. And then they came up with kind of an even smarter idea, which is kind of crazy. So they said, okay, now that we've trained the model to be like pretty good at writing poems and stuff like that, let's get a bunch of people in the room and have it produce 5 outputs, like 5 poems, and have the humans rank the best poem to the worst poem, 1 to 5, right? And then we'll take that score and we'll stick that in another AI system called a reward model. So here's the best, here's solving a problem. The first one did a bad job solving a problem. The bottom 3 did okay, and the 5th one did a good job. Stick that in the reward model. So let's teach this other AI system what good output looks like rather than relying on humans. So they trained up this other AI system, and then this other AI system went crazy on GPT-3 and produced ChatGPT by going a billion times, good output, bad output, good output. And that's where we are today. That's how we arrived at ChatGPT being so good and so responsive. And then they basically did a much better version of this with GPT-4, which is the latest version. Okay, so this thing is not perfect. It definitely makes mistakes, and these are called hallucinations. I do think there's a path forward for reducing that. You definitely have to double check some of the outputs, but this thing is amazing. It's the biggest thing, the biggest breakthrough I've seen in my 20 years of studying this. So as you can tell, I mean, for good and for bad, I think it's going to be disruptive for society, and we need to get ahead of it. I don't think it's going to be, I don't subscribe to the AI is going to take over the world, and that, I think that's kind of nonsense. But I think it is going to be disruptive for jobs and all sorts of ways, but also good. I think it's going to accelerate research and create new knowledge and things like that. Okay, so let me pause there and just take questions because I've thrown a lot at you. Your heads are probably going to explode from all that stuff, but hopefully you have a gist of at least how GPT works. Yeah.